Hi everyone, and welcome to today's lesson. This one is on equivalence and consistency, utilizing truth table analysis. So let's talk about equivalence first. The steps are very simple. In fact, go ahead and follow the steps from the previous editions of truth table analysis. The difference is in the rules that we utilize once we have completed our truth table. So the rule for equivalence is the following. If two formulas on top of a table have matching final columns, then they are equivalent. If the final columns do not match, then the formulas are not equivalent. So I've symbolized two sentences from our examples in the lesson, and here they are. And let's go ahead and check if these statements are equivalent. So the first thing we do, of course, is write out the expressions in TL, the formulas of TL. They are shapeless right now. Let's give it some shape. Now, because there are two sentence constants, we know that there should be 5 rows. And you can see here I've given a column to each of the components of the expression, except for the grouping indicators. Okay, now we fill in the TVAs, the truth value assignments. Here they are. It has to do with the atomic sentences of TL, or the simple sentences. And I've done it all in one step, because you know that anything that you can find in the A column on the far left should be copied and pasted into every other column where A is a simple sentence. Similarly for B, again on the left, you just copy and paste it wherever you see a B column in the formulas themselves. So I've just done that into one step. Next, we have to identify the final column of each sentence. The sentence in blue, the sentence that was previously referred to as A, you can tell that the tilde there is the main operator, because it applies to the parentheses, which is the rest of the formula. And as far as the green sentence goes, the main operator there is the ampersand, because it applies on its left to both the tilde and the A, and on its right to the tilde and the B. So that's the main operator for that one. Okay, now we do what we do. We calculate the small operators first, working our way out. So I've done that just in one step. This should be pretty easy for you now. And then let's calculate now the final column for each of these sentences. There it is for the tilde, there it is for the ampersand, and we're set. Okay, let's now remind ourselves of the rule for equivalence. If two formulas on top of a table have matching final columns, then they are equivalent. If they don't match, they're not equivalent. Well, let's take a look here. The final column for the tilde on the formula on the left is FFT. The final column for the ampersand for the formula on the right is again FFT. It looks like we basically, the TVA we've given exhausts the possibilities, right? Those are the only possible truth value combinations. And it looks like the final columns are exactly the same. That means these expressions mean exactly the same thing. That means, my friends, we have equivalence. Fantastic. Let's think about consistency now. Here is the rule. Given two or more formulas side by side on top of a table, if there is at least one row where the main operator for all the formulas is true, then the sentences are consistent. If there is no row on which the main operators are true, the sentences are inconsistent. Okay. Well, I've given us a set of sentences here, A, B, then H, B. Now, they don't mean anything in particular. We just want to get down the idea of how to test for consistency. We will get to more intricate examples later on. But let me just show you how consistency works as far as truth table analysis goes. Okay, this part is should by now be pretty straightforward to you. At this point, because we have 3 sentence constants, we do need all 9 rows, and this is as big as it'll ever get as far as our truth tables goes. And of course, it goes by 4s, by doubles, and then by singles. A gets T, 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 F, 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 F. B gets T, T, F, F, T, T, F, F. And H goes TF, 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 TF. Okay, we copy and paste. And we find the final columns for each of these. Actually, it's pretty simple for A and B. It's really just that column. Let's go ahead and calculate this here horseshoe column for the middle expression, and then we can have that final column already figured out. So here it is. Remember, conditionals are only false when you have a true antecedent and a false consequent. As such, we only have 2 falses in that particular column, near the top and right near the bottom. Those are the only 2 F's we have. Okay, now that we've done that, it's very simple how to check for consistency. All we have to do is see if we can find a row where every single final column is true. That's all it really means for when we say things like it's possible for all the sentences to be true simultaneously. That just means if we're using metaphorical language that they don't clash, they don't conflict. It's possible that they're all true at the same time. So as far as truth functional analysis goes, all you need is a table where the main operator or the final column for all these sentences are true. That just means it's possible for all of them to be true. So here we see A is true. If B, then H is true, because the true is under the horseshoe. And B is true. There is a row right there where every expression is true on the same truth value assignment. This, of course, my friends, means this set is consistent. So, quick recap. For equivalence, all you need is the final columns to match. And for consistency, all you need is one row, just one row, where the final column is true for all of the sentences. And that's it. Have fun.